Hey guys, welcome to video 2 in this series. So we are trying to solve a problem statement where we are trying to analyze the performance of an Azure storage account. This is something that I've never worked before, and I guess most of you guys might be watching this for the first time. So there have been quite a few learnings for me, and I'll try to share that with you as well. So first of all, we have raised a ticket with Microsoft on this, and also I've raised this as a question on the Microsoft Q&A website, as you can see on your screen. And again, to summarize, the problem or the answer that we're looking for is why the storage account is performing slow. The QA storage account, or you can say one storage account, is performing slow as compared to the other storage account. In this case, it was the dev account, even though both the storage accounts have been configured with the same settings. The dev storage account has more data as compared to the other storage account, which is QA. But we are trying to see why it is performing slow. And again, other important factor is both the storage accounts are being fed the same workload. And also the workload is being orchestrated by a same ADF pipeline, Azure Data Factory pipeline. So these are two important factors, because if you have everything same, why the one storage account is giving us an issue and why the other one is not giving us an issue. So let's look at one of the answers that we received. I'm not going to go into each line that have been written here, but few observations that we can draw from here is that you can read this, that the default maximum request per storage account is 20,000, and on a single blob it is 5,000. Now I'm not able to comprehend this entirely, but what it means is that if you have the request coming in, if you look at the blob storage versus, sorry, if you look at the single blob versus the storage account, I think the maximum request that can be sent per second are 500 and 20,000 respectively. So now let's try to look at this metric by going into the Azure portal, so which is already open. So this is our QA portal, QA storage account. And another thing that I want to tell you is that the issue seems to have been resolved, but I will not tell you the answer for now why the issue or how the issue has been resolved. But just let's look at this. So I think this metrics give you the idea of the transactions by storage type, and it doesn't necessarily give you an idea of just the number of transactions on a single block. So what I would do is I would reply back to Martin in this case, and I'll try to find out how can we check these two uh, metrics, that is metrics at a single blob versus metrics at the storage account. So now let's look at this. So here you can see that the number of requests at a given point in time went as high as 7K, and we saw no decrease in performance. So this means that this might be at the storage account. So had it been more than 20,000, we would have seen issues, and in that case we would have to change the architecture of our ADF pipelines, how we orchestrate, how we run the jobs or threads in parallel. But in this case we don't have to do that because it is below the recommended limit. I'm also, I would also try to find out from Martin from where has he got these, metrics. Maybe it is from Microsoft documentation, and I'll try to share that with you. So please remind me if I forget, or you can, remind me in the comments box below. So this is one of the learnings. So how you can apply this learning is when you are, invoking the for each loop activity or nested for each loop activities. Although you cannot have a nested for each loop activity, you can have a for each loop activity, then you can call a pipeline, and that pipeline in turn calls for each loop activity. So when you're configuring that, make sure that the number of threads in parallel do not go beyond 20,000, and you can check this by looking at the storage account insights. So that is one thing. And the other thing is that I told you in the beginning or just a while back that we had raised a ticket with the Microsoft as well. And initially they told us that you have to look at your architecture of the ETL flow, the AT flow that you have built. But we try to convince them, that the architecture looks fine. Otherwise, why would one environment work better than the other one? So then they actually reached out to the product team, that the storage account team, and eventually they found that the decrease in performance, or the 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 reason behind the timeout errors that we were getting, or the reason behind the throttling errors that we were getting, was because there was a bad node in the server. Or so think of it like a distributed system where you have multiple machines storing the data and computing the data. So they were saying that they found a bad node over there. So this is a significant finding. So after resolving that, after making sure that the bad node is taken care of, we saw increase in performance. And that is why you see here, the performance has increased, even though the number of requests are sorry, you will not be able to see the performance here. It's just the metrics for analyzing the performance of ADLS. So that issue has been resolved. But when we compare the dev performance with the QA performance, it's not quite up there. It's not matching 100%. And another finding that we got from that is that because the latency is high. So when we spoke, or when I spoke to the Microsoft executive, she told me that it could be because of high latency, and she told that you should check your latency, and it should not reach 4 seconds or 5 seconds. If it is in milliseconds, then it is good, or even if it is less than 1 second or 2 seconds, it is good. But if it goes beyond 3 seconds and reaches up to 5 seconds, it could be alarming. So in those cases, we definitely have to reach out to the Microsoft team, because everything is managed by them. We are just using this as a service. So we have to reach out to the backend team in order to analyze that. So we have done that. So we are just waiting for the answers. So yeah, it's been a good learning experience. So I would just like to summarize what we have found. First thing is that the number of requests per second should not go beyond 20K if you are talking about the storage account, and should not go beyond 500 if you're talking about a single blob. Again, I would have to see or check with Martin on how to get this figure for storage account as well as for a single blob, because it seems like on the store on the storage account it is available. It actually indicates the metrics is applicable to the storage account. So that is something that we'll have to check. And the other learning is that you should always look at the latency graph. If it touches 3.5 or it is approximately near to 5, you should actually reach out to the backend team. So yeah, I'll keep you posted. I don't think I would have if I know anything new. If I have anything new, I will definitely post it, especially about the latency, because as I said, the throttling issue is not occurring anymore, and that is because they identified a bad node and they fixed that, which is good on their part. And a special thanks to Shraddha, or shout out to Shraddha, who is from Microsoft and has been working with me in order to resolve this. So yeah, let's meet in the next video, guys. Till then, take good care of yourself. Thank you.